Vocabulary and Reading Introduction video. My name is Charles Benitez, and I, along with Camilo Rivera, created this project over the semester. Our project owner was Sayed Hassan, and we worked with mentors Eric Dwyer and Mohsen Tahiri. Our problem definition: the point of our app is to help students learn languages more effectively, and the project owner believed that if the students had a way to easily parse words that they would be learning and have an easy way to find definitions for these words, that it would assist in their grasp of the new language, which in this case is English. So our problem question is, can we use technology and linguistics to solve this problem? So this is our Gantt chart. This shows the different sprints and the amount of weeks that it took to complete each sprint. You can see each sprint was 2 weeks, and there are 7 sprints that we completed over the semester. So some requirements: we have many user stories, but here are 5 basic requirements of the system. The first, of course, is the landing page, or the main splash screen of both applications. Setting up the MySQL database was a main user story. Since the entire app depends on the MySQL database, that was one of the first requirements that needed to be completed. Then interfacing MySQL to Express and to the main stack. Categorizing the words is the main functionality of the app, where we have 4 main category lists: low, medium, and high frequency, and then the academic word list. So we give any given string of input and tokenize the string, and basically check to see if each token is in one of the categories, and then color code them accordingly. And then finally, uploading and scanning PDF files and being able to use PDF as input into the categorizer algorithm. So this is our first user story. There's a sequence diagram and UML diagrams of the landing page. This is simple, just showing the landing page and then viewing the K1 or low frequency list. Then setting up the database, of course. Users need to store data, and here's the all relevant diagrams. And same thing here, interfacing it with Express and Node. And then this is categorizing it. Categorizing all input, we see that we go to our landing page, we access our word lists, and when we're in the system, we're able to enter and process text, and the database is queried as a result. Scanning from PDFs, we do basically the same. It's the same documentation. We're just using a different way of inputting into the software. And so once that all the APIs have been figured out about PDF and being able to use PDFs as input, that all works fine. The problem that we found with PDF is that we're able to use PDFs into our app if they are text-based. But if they are image-based, like a scan of a textbook or something, we are not able to use that in our app yet, as that would be part of optical character recognition, which is something that we were not able to implement this semester. Okay, so moving on to system design. The system is composed of two subsystems: the web application and the actual admin website. And the website uses PHP and MySQL, and the web app uses JavaScript in the main stack. The main stack, of course, uses the mono-view controller architecture, and the website just uses a simple client-server architecture through PHP. The hardware requirements that we use were our own laptops, our own personal computers for development. We used XAMPP as a testing server, as XAMPP has Apache and MySQL, and all the different like preset servers just made for testing. And then we have our actual server by GoDaddy, and that's a Linux host, a dedicated Linux host that we're using. The software requirements, like I said before, we use the main stack and PHP and MySQL. We use different environments. We used IntelliJ, and we used Adobe Dreamweaver as well. Our persistent data is maintained by MySQL databases, by design. From the very beginning, we know that we were going to use a MySQL database to store all the data and to manipulate all the data and to make all of our calculations and such. So therefore, the data is persistent because of the database. Security and privacy. Privacy is not much of an issue because we're not collecting sensitive data. We don't have user data. The only data that we collect is like example passages. But even then, that data is never stored on the server more than temporarily to parse the input. So the privacy isn't as much of a concern as security, but we are using remote hosts, so we are trusting that GoDaddy is secure in their servers. We use secure passwords, of course, and we used a certain amount of characters and symbols, and all the precautions that we needed to on our end. So for security and privacy, I think we're covered. Okay, so this is the class diagram of the entire Verse Admin website. As you can see, it's split into 4 basic sections. So the main index and the categorizer is in yellow. In red, you see the all of the categories, so the category lists and the dictionary functionality of the system. In green, there's a frequency chart, which was later deprecated, but the classes are still there to edit it because we were never told to remove it from the database. So originally the frequency table was supposed to contain all of the words, and then the categories were derived from it, but it was split in the middle of the project, so it's 2 different parts of the system. And at the bottom in blue is the self-sustaining update functionality of the system, where you are able to import CSV files and they are automatically parsed and automatically generated a SQL query to load data from those files. As you see in the bottom, you are given a chance to truncate the table, which means erasing everything that's already in the database and starting from scratch before uploading your data. That's its a whole other subsystem, but you see the entire class diagram as a whole there. Now this is an example of a state machine. So we translated the categorizer algorithm into a state machine. So we have one main state, that's the final state, the waiting for input, that's the idle state. And so basically while there is input, it's going to go one by one for each token, categorize it, find it in a list, and if it's in the list, it's categorized, and then the system has to color code the token. So it's colored in one of 4 colors the user selects depending on the category, or it's colored in black if it wasn't categorized. So those are simple states that feed into each other and are a model for the behavior of the system. This is some screenshots of the main algorithm of the categorizer. At the top you see the algorithm, a level 4 loop, a quadratic search of an array that's implemented in JavaScript. On the bottom you have the implementation in PHP. You see there's a helper function written that search for a needle in a haystack. It's searching for an element in an array, and then color coding on the left depending on the font colors that were chosen by the user. And that stays persistent through post and updating the values every time that the user updates something, but it remembers the last choices that were made by the user. These are some test cases that we wrote. We created some tests on the server using XAMPP, like I had mentioned earlier. That basically is saying that all the categorizer functionality works correctly, and all the data that we are storing is staying persistent and staying accurate. And that concludes our presentation for the introduction of VIR, and thank you for listening.